Time is the one thing we can't stop, can't slow, and can't escape. It sweeps us forward from birth to death, carrying galaxies and memories alike. Every clock tick, every sunrise, every heartbeat reminds us that the universe is moving. And so are we. But for all our understanding of space, motion, and matter, we rarely ask a deceptively simple question. Why does time move only in one direction? Why can we remember the past, but never the future? Why can a glass fall and shatter, but never unbreak? Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're exploring one of the most haunting mysteries in physics, the strange, relentless flow of time, and why it only moves forward. If you rewound the universe, the equations would still work. Newton's laws, Maxwell's equations, and even Einstein's relativity all remain valid whether time flows forward or backward. A planet orbiting a star looks just as correct in reverse. The math doesn't care. In the microscopic world, particles don't seem to obey a direction of time at all. To them, the past and future look identical. So why do we experience something entirely different? A universe where causes precede effects, where memories exist only behind us, and where entropy, not symmetry, rules everything we know. The answer begins with a quiet law that underlies the cosmos, the second law of thermodynamics. It says that in any natural process, the total entropy, the measure of disorder, will always increase over time. Entropy isn't just chaos or randomness. It's the measure of how spread out and irreversible energy becomes. Imagine dropping an ice cube into a cup of hot coffee. The cube melts, cooling the drink until everything reaches an even temperature. What you've just seen is entropy increasing. Energy flowed from hot to cold, from concentrated to dispersed, and that flow can't be reversed on its own. You'll never see the coffee freeze while the melted ice cube reforms. This tendency for entropy to increase is what gives us the arrow of time. It's not that time itself has a preferred direction. The fundamental laws don't demand that, but the universe does. From the Big Bang to this very moment, entropy has been climbing step by step, process by process. The early universe was a place of unimaginable energy and astonishing order. It was dense, uniform, structured, a cosmos of low entropy. From that moment forward, disorder has spread like a tide. Galaxies formed and scattered, stars burned and died, planets cooled, and life arose, all following the same thermodynamic script. Entropy explains why you can't unscramble an egg, unmix paint, or unburn wood. It's the hidden rule that dictates why history can't play backward. In principle, the equations allow a reversed universe, one where broken glasses reassemble, smoke returns to candles, and people grow younger. But statistically, the odds are so impossibly small that the universe will never realize them. Entropy doesn't forbid reversals. It just buries them beneath numbers too vast for reality to climb out of. And yet, there's a kind of poetry in entropy's rule. Without it, nothing would ever change. A perfectly ordered universe frozen in balance would be timeless. A cosmos where nothing happens because nothing can. Entropy is what drives everything forward. It's what allows stars to shine, rivers to flow, and life itself to evolve. Without the relentless spread of energy, there would be no story, no growth, no movement. In a way, entropy is both the destroyer and the creator, the reason everything falls apart, and the reason anything exists at all. But time is more than entropy. Einstein revealed that it's part of the very fabric of reality. Space and time weave together into spacetime, a four-dimensional continuum shaped by energy and mass. In this view, gravity isn't a force pulling objects downward. It's the curvature of spacetime itself, and that curvature distorts time. The stronger the gravity, the slower time runs. Place a clock near a black hole, and it will tick almost infinitely slower than one far away. Even here on Earth, time moves a tiny bit slower at sea level than at the top of a mountain. The difference is minuscule, but real. Einstein's relativity showed that time isn't absolute. There's no single now shared by the universe. What you call the present might be someone else's past or future, depending on their motion and location in spacetime. For a photon of light, time doesn't pass at all. From its perspective, the moment it leaves a star and the instant it strikes your eye are one and the same. Past, present, and future may all coexist within spacetime, a vast cosmic tapestry that simply exists. What we call the flow of time might just be our limited way of experiencing that static whole, one frame at a time. But if that's true, why do we feel time moving forward? Why does our consciousness seem to march from past to future, never the other way around? Some physicists believe the answer, once again, lies in entropy, not just in the universe, but in us. Our brains record memories in one direction, because information, like heat, can only be stored as entropy increases. You remember breakfast because the physical act of remembering, the rearranging of neurons, the flow of energy through your mind, is an irreversible process. It's a thermodynamic event, bound to the same arrow that governs melting ice and dying stars. In that sense, the arrow of time is psychological, as much as physical. It exists because we are made of matter that obeys the same rules as the universe. Every thought, every memory, every sensation is built upon the irreversible consumption and transformation of energy. Our sense of now is a byproduct of entropy, increasing within the biological machinery of perception. And then there's the quantum world, where time becomes even stranger. At the smallest scales, particles don't behave in predictable ways. They exist in clouds of probability, smeared across space and time until observed. When we measure them, those possibilities collapse into a single outcome, a moment of decision that feels like the passage of time. Some physicists think time itself might emerge from these quantum interactions, that each collapse is a tick of the universe's hidden clock. Others propose that time doesn't flow at all, but constantly branches. Every quantum event splits reality into countless versions, each with its own timeline. In that view, the arrow of time isn't a single line, but an infinite tree of possibilities, each one as real as the next. Whatever the case, one truth remains. In our observable universe, time moves one way. Galaxies drift apart as space expands. Stars burn their fuel and fade. Even black holes, those cosmic abysses where gravity crushes time to near standstill, slowly evaporate through Hawking radiation, returning their energy to the cosmos. The universe itself is on a one-way journey from low entropy to high entropy, from birth to heat death. In the distant future, perhaps trillions of years from now, that journey will end. Every star will have burned out. Every atom will have decayed. Energy will be spread so thin that no structure, no heat, no motion will remain. Entropy will reach its maximum, and the universe will fall into perfect equilibrium. A silent, dark, unchanging expanse. With no gradients left to drive change, time in any meaningful sense will stop. There will be no before or after, only endless stillness. That might sound bleak, but it also reveals something profound. The same law that dooms the universe to decay is the one that made it beautiful. The arrow of time gave rise to stars, to chemistry, to life, to thought. Entropy doesn't just erase, it writes, it sculpts, it transforms simplicity into complexity, potential into history. Without the forward march of time, there would be no becoming, only being. So maybe the real mystery isn't why time moves forward, but what it means that it does. Why does the universe, in all its vastness, allow us, fleeting creatures of dust and memory, to experience its unfolding moment by moment? Perhaps consciousness is the universe's way of witnessing its own motion, the spark that turns physics into meaning. In a cosmos governed by decay, awareness is an act of defiance, a pattern that looks back and says, I am here, for now. Every second that passes is a reminder that existence is temporary, and that's what makes it precious. Time's one-way flow gives shape to everything we love, everything we fear, everything we are. The arrow of time is the thread that turns chaos into story. In the end, Every answer we find only deepens the mystery, and that's what keeps us exploring. This is Mattermosaic, piecing together the universe one discovery at a time. If this video sparked your curiosity, leave a like, share it with someone who loves science, and tell us what you'd like to explore next. Subscribe for more weekly journeys through the fabric of reality.